Hello and welcome to Ceazor Snack Sandwich. Today I have a really quick video for you on what is a based rollup. Now this does not go into extremely in-depth the technology or the system that's inside based rollups, but it's going to give you a nice good overview of what is a based rollup and what is the motivation behind based rollups. Now I've been talking to people about this Rise chain, part of this team here, and it's one of the features that Rise is aiming for, which is based rollups. So there are some articles out there. You can go to the Rise book here, up here, Rise book, and you can read through this article. It kind of explains it pretty well. You can do a Google search and you can come across Tycho's Mirror article, which is a little bit more in depth and talks a lot more about it as well. And then, there are other articles around if you Google based rollups, okay? I'm going to use a flowchart to kind of explain to you just generally what a base rollup is and what is the motivation behind it, and kind of give you a starting point or a foundation on based rollups and rollups in general. So let's swing over to the flowchart now. Rise is the next generation high throughput based rollup. Rise chain is ushering in the gigagas era with a parallel execution engine and a continuous pipeline. Find out more at riselabs.xyz. Okay, so here we are on the flowchart. We have dollar bill on one side and we have boosted bill on the other and Ethereum inside the middle. So in order to understand what is a based rollup, we kind of have to understand what is a rollup and what is the motivation behind just a rollup. And the point of it is like to scale Ethereum to allow more users to interact with Ethereum and to keep prices down. So let's kind of go through what the situation is up until now. So we have Ethereum, the network, right? That's what we're calling mainnet nowadays. So it's very decentralized, it's very secure, but it's slow and expensive. So when I say slow, it costs it's like 12 seconds per block or slot, whatever you want to call it, and it's expensive. So sometimes it can cost you like 40, 50, even maybe $100, $200 to send a single transaction, depending on the complexity of that. However, it is the biggest decentralized network of validators. There are like thousands of validators. Some are like solo validators, so somebody running a validator in their basement, and some are institutional validator stacks like Lido, who have a whole bunch of validators running with a staked ETH and so forth. Secure is because it's so decentralized. There are so many. It's censorship resistant. So if a government were to censor or ask a certain individual or company to censor some transactions, there would be other validators in other countries that could get your transaction onto the blockchain. So it's censorship resistant, secure, decentralized, but it is slow and expensive. So instead of trying to fix the network, the Ethereum network, and try to make it good in all three factors, which is like questionably impossible, they've decided to do what they call scaling. So dollar bill, let's say dollar bill is a large whale. He has a lot of capital. He can send transactions no problem. So let's kind of go through the flow of what it means to send a transaction on Ethereum or EMV or even most blockchains in most cases. So he has a transaction or an idea. Maybe he wants to swap one token for another token, or he wants to deposit his tokens into some sort of staking protocol or some sort of protocol that will earn him some sort of interest, right? So he submits the transaction to the Ethereum network, so to speak, uses his MetaMask or his wallet, submits the transaction. Then that transaction is added to the mempool. So it's sitting inside a whole bunch of other transactions. So there's a whole bunch of transactions there. Hey, we want to send these transactions. These are the things we want to do. And then the builders will kind of go through, and the searchers, they have this searcher builder searcher builders. They're kind of the same thing, but a little bit different. So these builders will go through this mempool, and they will select the transactions, and then they will order them. And then they will give those to the proposers, who will propose, validate, and confirm. So like put those, make sure they're legitimate, and put them onto the blockchain as transactions that are finalized, right? So that's kind of the general idea of how the blockchain works and how like a transaction works and so forth. Moving on. So we have Dollar Bill. Dollar Bill has big money. He's patient. He doesn't have to worry so much. He's doing, safe, conservative big transactions. So he doesn't mind to pay to wait and pay the general good, the high amount for a single transaction of like $40 or $15 or even like $5, right? He doesn't mind this. Like if he's sending $1 million into some sort of contract to earn 10% or 15%, he doesn't mind paying $5 or $40 because he will get that back in a short amount of time. However, we have Boosted Bill here, who is small. He has small money, and he wants to be more agile. He wants to do more degenerate stuff or more trading and changing his positions a lot. So if he wants to do that, this situation of being slow and expensive is quite bad for him, because he's going to pay the gas fee frequently, and he's going to have to wait 12 seconds for each transaction that he wants to do. So that's not an ideal situation for Boosted Bill. So instead, what they've done is they have created all of these different rollups. So there's all of these different L2s they are much more centralized, right? So because they're centralized, they're able to, give up the decentralization and make it fast and cheap. So instead of waiting for the network to receive his transaction, get it into the mempool, and do all of this with the Ethereum network, they are putting all of this, most of this stuff onto their own centralized servers. So it gives up that decentralization and security to increase the speed and make it cheaper, okay? However, in order to kind of inherit some of the security of the of Ethereum blockchain, what it does is it rolls its state down into the Ethereum. So it's called roll the state like down. So after some time, Dollar Boosted Bill has been sending all these transactions, so have all these other people to, let's say, one of these blockchains like Arbitrum, right? So he's been sending all of these blockchains, all of these transactions, and then that state, that situation, what is the current ledger on Arbitrum is printed down on Ethereum. So if Arbitrum ever has some sort of problems, then they can always fetch that data, that state, from the secure and decentralized network that is Ethereum. Now it says here L2Beat. I put this here because L2Beat is in control of any of these L2s, which we have here. We have Arbitrum, Base, Optimism, ZK, and Blast. There's many, many more. The reason why I put L2Beat here is because there is a website called L2Beat that I would suggest you to kind of go to check out. It's, some people love it, some people hate it, but it looks like this, and it basically kind of goes through and allows you to see all the different L2s, the different kinds of L2s, the risk factors of each of those L2s. It's a fantastic resource for anybody who's trying to research L2s and which L2 they want to use. So I would suggest you to kind of check out L2Beat, and it's l2beat.com. Now, there are a lot of choices now for rollups, something like 130 or something like this. There's a substantial amount of choice now, and they all have their own like levels of security, centralization, speed, and cheapness, and so forth. So do some research on that. So they have this thing called the conical bridge, and this is kind of like Ethereum is on Ethereum, right? That's where Ethereum lives. But all of these L2s, or not all of them, but a large amount of them are using Ethereum as the transaction payment or the gas payment token, right? So they need Ethereum on them. So there's a contract, so like Arbitrum will build a contract on Ethereum, and you can put your Ethereum inside this contract, and then it will mint you Ethereum on Arbitrum. So these conical bridges, they have this like permissionless exit for some of these blockchains. So basically, as the blockchain upgrades itself and becomes more and more secure and more decentralized, and these L2s become more and more safe, then there is this ability for you to withdraw your assets from that contract on Ethereum, even though the Arbitrum may be down. Like, let's say Arbitrum just gets shut down for whatever reason, and your assets were bridged up there through this conical bridge, then you can most likely be able to pull your assets out. So every L2 will have different levels of this. So not all L2s will give you this permissionless exit. So you want to kind of look for this and find out, does that L2 have this permissionless exit? Can I get out even if that blockchain is closed down? And then fraud proofs, there are some different kinds of fraud proofs. I don't want to get into all of them right now, but there are different kinds of fraud proofs. So there are a couple different kinds of blocked L2s, and one of them is a optimistic rollup, which kind of basically means they're going to just keep sending their state down to Ethereum, and then if someone thinks that state was incorrect, they can challenge it, and that window is usually about 7 days. So they have these, they're called optimistic because they're like, yeah, it's right unless someone says no, it's not, right? So it's optimistic. And then they have these ZK rollups, which are they send down the state with just the proof, like just they don't how to explain it? They don't send down all the data, they just send down the situation. If you can kind of think of that, they're called zero knowledge proofs, and it's pretty hard to explain it in a small amount of time. So just kind of think of it that there are these two opportunities, and people do believe that zero knowledge proofs are superior to optimistic proofs because they don't need to be challenged because they are proof that they are true. But a lot of the L2s currently are running on optimistic rollup systems. Okay, so moving on to the next part. So one of the problems with these L2s is that these L2s aren't really interoperable. Okay, so if you are on Arbitrum and you want to do something on Optimism, then you need to send your assets from Arbitrum to Optimism because they are siloed different blockchains, so to speak. So you could go down to Ethereum and then use the conical bridge to go back up to Optimism, but this would be quite costly and wasteful, especially for a boosted bill here, right? So third-party bridges have sprouted up in this to fill in this need. So you can send your assets from Arbitrum to Optimism through a third-party bridge. Now, this third-party bridge doesn't inherit almost any of the security that is found within Ethereum, and I'm not exactly sure, but I'm pretty sure it kind of doesn't give you the right to these permissionless exits anymore. So there is a little bit of risk there, but if you are like a dollar boosted bill, this is pretty much the best choice for you to use any of these third-party bridges, okay? Now, there is a little bit of interoperability inside these L2s when you see the OP network. They have this thing called the superchain, where the OP is kind of licensing or giving out their tech, and the other chains are using that tech to kind of make their blockchain very similar. So you can kind of think of it like, in this case, we have Optimism and Fractal. You can kind of think of it like, oh, they are speaking the same language, so they can kind of, work together more smoothly than Arbitrum and Optimism can, okay? So there are some bridges between Optimism and Fractal, for example, and there are even some like apps that are kind of working on both of these, and the goal goal is to make it so that, like, if you have money or tokens on Optimism and you want to do something on Fractal, it will just happen. Like, that's the goal of this super chain, or this Optimism like network of like super chains. So it's kind of like they're interoperable, but they're only interoperable with each other, and these are not really interoperable at all with these other optimistic rollups, or these other rollups like Arbitrum or ZK Era, or these other technologies. Okay, moving on. Another problem with this system of L2s is that the developers who are developing dApps, like, so you want to build some sort of like swap or perpetual exchange or an NFT project or whatever that your developers are trying to build, they have to kind of choose which blockchain they want to use, or they have to deploy to several of them. Okay, so it makes the developer like use the developer experience a little bit harder, because now they have to manage like deployments on several chains, or they have to kind of guess who's going to get the most TVL, and whoever gets the most TVL will most likely be able to give them some of that TVL. The users will, you know, deposit in them, and they will get more success and more fees and for providing the service that their app provides. So this is one of the other problems with this L2 like system of scaling up Ethereum network. Now, the other problem is, like I've said, these L2s are generally very centralized, especially the sequencing. This down here, this submission of the transaction, it's a centralized sequencing. Okay, so the actual L2 is going to ask you to send them their transactions. They're going to sequence them, put them in order. They're going to put them onto their blockchain, and then they're just going to take that data and store it on Ethereum. Okay, so we've seen that some of these chains who are having massive amounts of transactions being sent on them, they are generating a massive amount of revenue for them. And these are centralized entities like Coinbase and so forth. So this is a questionable thing. Like, do you want a single corporation to be taking all the money from your transactions, all of the service fees from your transactions, and deciding what they want to do with that? There is a small fee that they have to pay to put their blockchain down, to secure their blockchain down onto Ethereum. But the amount of revenue that they're getting from sequencing people's transactions is enormous. Now, there's another concept called MEV, where people who are building these blocks, right, who are sequencing the transactions, who are putting transactions in orders, can move these transactions in a certain way where they can put their own single transaction in there and kind of take advantage of the fact that, you know, people have declared what they want to do before it actually happens. So, for example, if I want to sell some asset, then you can buy it before me, or you can wait until after I sell it, then buy it. Things like this. You can sell before me, and then I sell, and then you can buy back cheap. You know, things like this. So there are these possibilities of MEV extraction. That's a very big field, a very big discussion of how to deal with this. And because these systems are centralized, they can take all of this MEV value into themselves. So they can play these games without a permissionless system. So these L2s, generally speaking, are able to extract all that MEV. In the case of, like, you know, you're trusting that they're not going to do malicious MEV and just do like the minor MEV and so forth. So there's a little bit of problems with this centralization of these sequencing in these L2s. Okay, so an alternative is what we call like like I said, this superchain. This superchain can kind of, perhaps in the future, they can kind of share this sequencing so it becomes a little bit more decentralized, because Fractal and Optimism and Base and all of these guys, they're running their own sequencing service, right? They have their own sequencing and a transaction building, right, system, and they can kind of, because they're speaking the same language, they could possibly share this, and it's going to be fast. It's going to still can be like less than 1 second, or they can roll them down and just use the Ethereum sequencers, because there's already a huge network of Ethereum validators who are sequencing transactions on the Ethereum network, as well as these rollups are part of the sequence transactions and so forth. But so they can roll them down, but it still has this 12-second issue of this block time on Ethereum is 12 seconds, and that's kind of unacceptable. So it's kind of like an either or. So there is a solution to this 12 seconds, but as you can see, there is this issue of like, should we could solve this problem of this centralized big revenue MEV being controlled by a single entity simply by sharing the sequencing with other computers, like a network, whether it be a small network, an intra network like the Optimism superchain, or whether we sequence it down to the L1 and have the L1, which is a large decentralized network, to sequence these transactions for us. Now, there is this concept called pre-confirmations, which can kind of speed up this based rollup issue of like having 12-second blocks times. So it's kind of new in development and new at the point of this video, where they're kind of trying to research this and develop it and so forth. But the pre-confirmations basically means that there can be a system set up where Ethereum says to the user, yes, I will put your transaction into the sequence as soon as I can, so you're good to go. So it's like kind of like a receipt. Like, here, we've got your intent. Here's your receipt, and then we will get to work on your service, and we will take care of your business, so to speak, for you, and you don't need to worry. We will get it inside there. And if they do anything kind of malicious, or if they do anything kind of, if they forget, or this kind of idea, like, they're not going to forget because it's all computers, but if it doesn't go in, then they get slashed. So they lose money for not fulfilling their promise to the user that they will include their transaction inside the next possible block. There's a lot more technology. There's a lot more to talk about pre-confirmations. That could be a video all by itself as well as the MEV and so forth. So I just want you to kind of understand a little bit what's going on. Last one. So, like I said, the people are asking me at Rise, what is this based rollup stuff? And what I'm trying to do is kind of give people this little video so they can kind of understand it. So at Rice Chain, there is some benefits here. We have because of this like pre-confirmations, right? We have this sequencing that can be very, very fast, but also very, very decentralized. So an entire huge network can do it. So there is a separation of the actual execution of that transaction and the sequencing of that transaction when we talk about based rollups. So Rise Chain is going to be a very fast execution environment, but the sequencing is going to be done by the Ethereum network. So the Ethereum network doesn't need to have high performance machines who can execute and like kind of manage a whole bunch of transactions. They just need to put the transactions in order so that you don't have this centralized entity deciding whose transactions go first, second, third, fourth, and then being able to do MEV and have this enormous amount of revenue. So instead, what RiseChain is going to do is they're going to separate the sequencing from the execution environment. So the execution environment will still be very, very fast and have a lot of complexity and be able to give out like in a user experience where they have this concept called gigagas. So a lot of complexity into a single block, a lot of transactions and very fast user experience. But the sequencing, the ordering, where, you know, by putting transactions in certain order, there is the possibility to order transactions to do this MEV, and that will be sent down to the Ethereum network so that a decentralized party can take advantage of the benefits of sequencing transactions. So I hope this has been useful. I know it's kind of there's probably a lot of questions after this, but I just wanted to give people an idea of what's going on here so that you can then be like, oh, this is very interesting. I would like to learn more. And then you can kind of dig deep, go down the rabbit hole, try to find out some more stuff about this. So I hope this has been useful and interesting. I know this is not my general videos of like kind of covering a single protocol and talking about it. This is more about like an ecosystem or like a blockchain 101 type video. So thank you so much for watching, and goodbye.